On February 14th, 1946, the world met ENIAC. It was Valentine's Day, but this love affair was with technology. The unveiling of ENIAC marked a significant milestone in the history of computing. ENIAC, which stands for Electronic Numerical Integrator and Computer, was a marvel of its time. It was big, taking up an entire room. It was loud, with thousands of vacuum tubes humming and buzzing. It was the first general-purpose electronic computer, capable of being reprogrammed to solve a full range of computing problems. ENIAC wasn't like the sleek, compact computers we know today. It was a behemoth, a giant leap forward in technology. It filled a large room packed with 17,468 vacuum tubes, 7,200 crystal diodes, and 1,500 relays. It was hot, requiring massive cooling systems to prevent it from overheating. The heat generated was immense, but it was a revolution, a groundbreaking achievement that changed the course of technology. For the first time, complex calculations could be done at electronic speeds, far surpassing the capabilities of mechanical calculators. This was a game changer. ENIAC was born at the University of Pennsylvania's Moore School of Electrical Engineering, a hub of innovation and research. It was a project shrouded in secrecy, developed under the utmost confidentiality. World War II was raging, and the need for advanced technology was critical. The US Army needed a faster way to calculate artillery firing tables, which were essential for accurate targeting. These tables were critical for aiming weapons accurately. ENIAC was the answer, providing unprecedented speed and accuracy in calculations. The world was at war. Technology was advancing rapidly. The need for faster calculations was paramount. ENIAC was conceived in this crucible of conflict. Its initial purpose was purely military. The army needed to improve the accuracy and speed of artillery fire. Before ENIAC, calculating firing tables was a laborious process. Humans did the math. These human computers used mechanical calculators. The work was slow and prone to errors. ENIAC promised to change all that. The development of ENIAC was a massive undertaking. It involved a team of brilliant engineers and scientists. But behind the scenes, a group of women played a critical role. They were the programmers of ENIAC. They helped tame this electronic beast. Before ENIAC, the word computer had a different meaning. It referred to people. These people, mostly women, performed calculations by hand. They used mechanical calculators and mathematical tables. It was tedious and demanding work. These women were essential to the war effort. They calculated ballistics trajectories and other critical data. Their work was vital for the military, but their contributions were often overlooked. They were seen as invisible technicians. When ENIAC arrived, these women saw an opportunity. They could transition from human computers to programmers of this new electronic marvel. 6 women were chosen for this groundbreaking role. They would become known as the ENIAC 6. The ENIAC 6 were pioneers: Kathleen McNulty Maudsley Antonelli, Jean Jennings Bartik, Frances Snyder Holberton, Marlin Westcott Meltzer, Frances Beeler Spence, and Ruth Lichterman Teitelbaum. These women took on the challenge of programming ENIAC. They came from diverse backgrounds. Some were mathematicians, others were skilled in logic and problem solving. They had one thing in common: a passion for pushing the boundaries of technology. They were about to embark on a journey that would change the world. Jean Bartik programming ENIAC was unlike anything we had done before. There were no manuals, no programming languages as we know them today. We had to figure it out as we went along. We relied on our ingenuity, our mathematical prowess, and our sheer determination. Section 5. Blueprints and Brilliance: The Challenges of Early Programming. In the early days of computing, programmers faced a myriad of challenges that are almost unimaginable today. Imagine programming a computer without a keyboard or a screen. There were no monitors to display code, no keyboards to type commands. That was the challenge facing the ENIAC 6, a group of pioneering women who were among the first computer programmers.
They had to work with blueprints, which were the only way to understand the machine's architecture. These blueprints were complex and detailed, filled with intricate diagrams and technical specifications. They showed the intricate wiring of the machine, mapping out every connection and circuit. The women couldn't just type in code like we do today. They had to physically manipulate ENIAC, adjusting switches and connecting cables by hand.
They used switches, cables, and trays of punch cards to input their programs. Each punch card represented a specific instruction. Each change affected the machine's behavior, altering its operations in real time. It was a painstaking process of trial and error, requiring immense patience and precision.
Debugging was another challenge. When errors occurred, we had to trace the problem through the maze of wiring, often spending hours to find a single fault. We had to understand the flow of data within the machine, following its path through various components. It was like solving a giant, intricate puzzle, where every piece had to fit perfectly to make the whole system work.
Section 6. The Unsung Architects of the Information Age. The ENIAC 6 were more than just programmers. They were problem solvers, logicians, and pioneers in the field of software development.
We developed a deep understanding of ENIAC's architecture. We learned how to translate complex calculations into instructions the machine could understand. Our work laid the foundation for modern programming.
They developed concepts like subroutines and nested loops. These concepts are still used in programming languages today. They were instrumental in making ENIAC a reality.
Despite our contributions, we were largely unacknowledged for decades. Our work was seen as secondary to that of the male engineers who built the machine. It was a common story in the male-dominated fields of science and technology.
Section 7. A legacy rediscovered, giving credit where it's due. This section delves into the often overlooked, yet crucial contributions of the ENIAC 6, a group of pioneering women who played a significant role in the early days of computing. For years, the ENIAC 6 remained in relative obscurity, their names and achievements largely forgotten by history. Their contributions to the development of ENIAC, one of the first electronic general-purpose computers, and the birth of computer programming were largely unknown to the public. However, in recent decades, there has been a growing recognition of their pivotal role. Scholars, historians, and tech enthusiasts have started to acknowledge the immense impact these women had on the field of computer science.
Historians and computer scientists began to delve into the archives, meticulously piecing together the untold stories of these trailblazing women. They uncovered the stories of these remarkable women, who not only programmed the ENIAC but also laid the groundwork for future generations of computer scientists. They brought their contributions to light, ensuring that their legacy would not be forgotten. The ENIAC 6 began to receive the recognition they deserved, with ceremonies and tributes honoring their groundbreaking work.
Today, the ENIAC 6 are celebrated as pioneers in the field of computer science. Their names are etched in plaques, and their stories are told in museums and educational institutions. Their story is an inspiration to aspiring programmers, especially women, who see in them a reflection of their own potential and possibilities. They are a reminder that brilliance and innovation can come from anyone, regardless of gender. Their legacy continues to inspire and pave the way for future generations in the tech industry. Section 8. From ENIAC to iPhones, the enduring impact of early computing. ENIAC may seem like a relic of the past, but its legacy lives on. It paved the way for the digital revolution. It showed the world what computers could do. It sparked the imagination of a generation.
Without ENIAC, we wouldn't have the computers we rely on today, from smartphones to laptops to supercomputers. All digital devices owe a debt to ENIAC. It was the first step on a journey that has transformed our world.
ENIAC's impact extends beyond technology. It changed the way we think about information. It ushered in the information age. It made the world smaller and more connected. Section 9. The Ghost in the Machine. ENIAC's architectural relevance today. Even though ENIAC is long gone, its architectural influence persists. Computer scientists continue to study its design. They draw inspiration from its parallel processing capabilities. ENIAC's architecture, with its multiple units working simultaneously, foreshadowed modern parallel computing. Today, parallel processing is used in everything from supercomputers to gaming consoles. It allows us to tackle complex problems more efficiently. Researchers are exploring ways to apply ENIAC's principles to new technologies. They are looking at how to build more efficient and powerful computers. ENIAC's legacy continues to shape the future of computing. Section 10. ENIAC's legacy, a world transformed. 75 years after its unveiling, ENIAC's legacy looms large. It stands as a testament to human ingenuity. It marked the dawn of the computer age. It changed the world forever. ENIAC's story is one of innovation, perseverance, and the power of human imagination. It reminds us that we have the capacity to achieve extraordinary things when we push the boundaries of what's possible. As we navigate an increasingly digital world, it's essential to remember the pioneers who made it all possible. The engineers, the mathematicians, and the women programmers who dared to imagine a future transformed by computing. ENIAC's story is their story. It's a story that continues to inspire and shape our world today.